we're learning how to find for an inverse of a matrix. We said the inverse of a matrix A is written as this. This is how you write an inverse of a matrix A, or this is how you write an inverse of A. This is an inverse of A. And then we said when we see AB is equal to I, this I is an identity element. And this identity element is made up of zeros and ones, but the ones have been arranged in a diagonal way. Right. So this is an identity, this 3 by 3 identity elements. So when you see A multiplying B, and then it gives you an identity element, it means that this B is an inverse of A. Why? Because when you have A, you multiply it by its inverse, you get an identity element. It's like you multiplying 2 by half. Half is an inverse of 2. This half can be written as 2 exponent negative 1. So when you multiply 2 by 2 exponent negative 1, you get 1. And yesterday I made you understand that in matrix, the identity element is seen as 1 in real life, or as unity. That's 1. And then we were looking at how you can find the inverse of A. So assuming you've been given A, which is 2 by 2 matrix, so 2, 4, 6, let me write 1 here. And you have to find the inverse of this A. What we were saying is that you have to argument this to an identity element. So when you say you're argumenting this to an identity element, it's just you writing the element of A. 2, 4, 6, 1. Since the element of A is 2 by 2 matrix, the identity element is supposed to be 2 by 2. So you writing in this format is what we call you have argumented to this element, the identity element. So you argument it. So now what you are going to do is that you are going to, so here is A, this is the value for A, and this is the identity element. You are solving, so we see this A changes to an identity element, and this identity element will be B, or we change from its identity element to a full matrix. What I'm trying to say is that we are going to transform this matrix A until we see an identity element. Identity element is made up of 1, 0, 0, 1. This is 2 by 2. And then this I will also be transformed to an unknown. We don't know the value. So that answer that we get here will be the inverse for A. So let me write X, Y, Z, and let me write maybe O here. So this will be the final solution for matrix A. So we are just transforming, our aim is we transforming this A to look like an identity element. And the result here will be the answer, or will be the inverse for the matrix A. So let's visit the slides and then. Okay, so they said suppose B is any matrix that satisfies AB is equal to I. That's A multiplying B is equal to an identity element. So they go ahead and they said if you multiply the left side of both sides by A inverse, we get A inverse multiplying AB is equal to A inverse multiplying A. So they are just multiplying both sides by the inverse of A. And then we are saying that when A multiply its inverse, you get I. That's the identity element. That's what I showed there. When you multiply 2 by its inverse, you get 1. So any number multiplying by its inverse will give an identity element. Like any number multiplied by its inverse you get 1. And in matrix, and 1 is written like an identity element. That's the 0, the 1s, and then the zeros. When you multiply it by any matrix, you get the same matrix. Like you multiplying 1 by any number, you get the same number. So when you multiply an inverse by its raw number, like multiplying A inverse by A, you get the identity. And this is the B. And here is the inverse of A multiplying the identity. It's like so they wrote it here. And you can see here is the inverse multiplying B, inverse B, but here is only this is the identity multiplying B. The same thing here, but here is the inverse of A. Why? Because we said any number multiplying the identity element is the same number. It's like anything multiplying 1 is the same thing. 2, 1 is 2. So when the inverse of A multiply identity element, the result is the identity element. So the inverse of A. So this means that B must be the inverse of A. What they are saying is that this B is the inverse of A, because when you multiply B by the identity element, you have to get the inverse of A. So this is what we are proving. So here I said we are transforming this element of A to be an identity element, and then the values for this identity element will be unknown. So this unknown will be the inverse for the A, the matrix A. So our final solution should be something like this. So we have our identity element and this B. So this B represents the inverse for A. So identity element and this is the B. And that will be the answer for A, because we said any number multiplying the identity element is the same number. So if B times identity element will be B. And if B is the inverse of A, that means B is equal to A inverse. In some example, you get to know. So here we use a Gauss-Jordan method to find for the inverse of the A. I think they did solve example. So let me solve an example here. Using the same example, we are finding for that inverse. So A is equal to 2 for here was 6, and I think here was 0 or 1. No, this one. Yeah, and then we have to find for the inverse of this, matrix. So we said first of all we have to argument it. So argumenting is writing it in this format: 2, 4, 6, 1. You argument it by an identity element. So 1, 0, 0, 1. So what we are supposed to do now is to transform this A to an identity element. And how are you going to do that? So we have several ways of doing it. First of all, you can interchange row 1. This is row 1. This is row 2. So ways you can solve or ways you can transform this element to an identity element is that you can interchange row 1 for row 2. That is one way. Changing row 1 for row 2 will be like when you interchange row 1 and 2, you get 4, 1. 4, 1, 2, 6. And then you interchange this one too. So you get 0, 1, 1, 0. That's we interchanging this. So this one way you can solve it, like one process you can solve it by interchanging row 1 for row 2. You can also multiply one of the rows by a number and then subtract it from another row. So we can multiply, assuming we are to multiply row 1. Let's continue from this side. We have to multiply row 1. This is row 1 and this is row 2. So assuming we have to multiply row 1 by 3, assuming. So our row 1 will then be 3 multiplied by this 4. We get 12 here. 3 multiplied by 1, we get 3. And whatever that happens to this side must happen to this side too. So 3 multiplied by 0 is 0. 3 multiplied by 1 is 3. So we just multiplied row 1 by a number, that's 3. Then you maintain row 2. Here is 6. Here is 2. Here is 6. 1 is 0. Other way we can solve to get an identity element is by subtracting one row from the other row. So we can subtract row 2. So now here is our row 2. We can subtract this row 2 from row 1. Row 1. So it will be like 12. So it's row 2, right? Minus row 1. Okay, let's say row 1 minus row 2. So it will be like 12 minus 2. So these are the ways, or these are some of the operations that you can do in order to find the identity element. So you can either add, you understand, just a scenario like an example, like things that's supposed to be done. You can multiply through, you can interchange the rows, and then you can divide too. You can divide a row. So let's solve it. We are solving it actually. So our A, you have 2 here, you have 4, 6, and 1. Then we augment it. One, 0. Okay, so we have augmented the element of A, or the matrix A. So what we are saying is that in order not to be confused, let's solve it row by row. What we want, our aim is to change this matrix A to be an identity element, which is 1, 0, 0, 1. This is what we want to see the element of A turn into. So what you are going to do is that you are going to solve it column by column. So we solve this, we turn this 2 to 1. When we are done, we turn this 4 to 0. When we are done, we move to this place. We turn this 6 to 0. And then we turn this 1. It's already 1. So whatever the number is, you have to turn it to 1. So this is what we want to do. Okay. So first of all, how can we turn 2 to be 1? We can turn 2 to be 1 by dividing 2 by itself. So that 2 cancel itself 1. We get 1 there. And one thing is that whatever you are doing to this element, that's 2, supposed to be done to all the rows, like the first row. So if you are dividing, because you want to turn this 2 to 1, so you have to divide it by itself, which means you divide the 2 by 2, you divide the 6 by 2, the 1 by 2, the 0 by 2. So when we divide 2 by 2, we get 1. When we divide 6 by 2, we get 3. When we divide 1 by 2, we get half, and 0 by 2 is 0. The row 2 was not touched, we didn't touch it. So we have our 4 here, we have our 1, 0, and 1. So the only thing, or the only change that we made was to divide the row 1 by 2. Because we want to turn the element of A into an identity element. So now we have 1 here, we are done with this place. Our next target is here, to change this 4 to 0. And how are we going to change the 4 to 0? So we can turn this 4 to 0. So this is row 2, so we say row 2. The element is 4. So we say row 2 minus 4. When you subtract 4 plus 4 from 4, you get 0. But then you have to multiply it by something. You have to multiply it by one of the rows. So assuming this one is 3 by 3 matrix, you're supposed to choose one of the rows, so you multiply it. But here is the case, we are dealing with only 2 by 2 matrix. So the row, we have only 2 rows, row 1 and then row 2. Therefore, we have to multiply it by 1. So we say row 1 here. So the formula that we are using is that row 2 minus 4 multiplying row 1. And we know row 1, the corresponding here is 1. So we have row 2, which is 4. 4 minus 4 multiplying 1 here. So we multiply 1 by 4, we get 4. When you subtract 4 from negative 4, is 0. So our next stage, we have 1 here, we have this 3 here, this is half, 0, and then we've worked on this 4, and now we have 0 here. We perform the same operation on this one. So we said row 2 minus 4 row 1, and then row 2 now is 1. So this 1 minus the 4. But now the row 1, which corresponds with this 1 on the row 2, is 3. So here is 3. So we multiply 4 by 3, which will get 12. Right, so it's 1 minus 12. And that will give us negative what? 11. So we have negative 11 here. The same operation. This is 0. So it's like 0 minus 4 row 1. And what is row 1 here? Row 1 is half. So we multiply it by half. And what will you get when you multiply 4 by half? So here will be negative 2. Our next target is this place. This is 1. So we have 1 minus 4 multiplying. The row 1 is 0. So here is 0. 4 by 0 is 0. So here you have 1 here. Are you even getting it? So we are done with the first column. So we are now moving to the next column. And then this next column, we are changing it to be, we are changing this 3 to be 0. We want this 11, negative 11 to be 1. So first of all, because we want to change this negative 11 to be 1, first of all, let's work on that one. So what you are going to get, so we have 1 here, we have 0 here, we have 3 here because we are going to work on the negative 11, we have half here, and we have 0 here. So our question is, how can we turn negative 11 to be 1? We just divide by the number itself. When you want to turn it to a unity, divide it by the number itself. So it's like negative 11 divided by negative 11. So you get 1. But then you're working with a formula or a structure. So we say root 2 divided by negative 11. So when you divide 0 by negative 11, it will be 0. That's why I have 0 here. When you divide negative 11 by negative 11, you get 1. So we have 1 here. So here we have to divide this negative 2 by negative 11. So this will cancel this. So we have 2, 11 here. We divide this 1 by 11. You have 1 over 11 here. So you've been able to change this to 1. So now we have to work on this 3. And we have to change this 3 to 0. How can we change this 3 to 0? The only way we can turn 3 to 0 is by subtracting 3 from 3. But then when you subtract 3 from 3, you have to multiply it by something. Multiply it by a row. And the reason why we change the negative 11 on the second row to be 1 first before we work on the 3, because we wanted to do that so that when we are subtracting 3 by 3, we can multiply it by something. That thing's supposed to be 1. Because aside 1, there's nothing that you can multiply by 3 that you have to get the same number. So that's why we worked on this 1 first, so that we can have 1 here. So that when you multiply by a row, the row will maintain itself. Like 3 by 1, it will be 3. So if you study things, you could still say here we first worked on this one to make it 1, so that we can get this 0. And when we get to the second column, we first worked on the 11 to make it 1, so that we can find this 3. Okay, so we are turning this 3 to 0. So we quote our formula. We said row 1 minus 3 multiplied by row 2. So this is the formula we are using. So 1, we have 1 here. So we have 1. We said minus 3, so 3 multiplied by row 2. And row 2 here is 0. So you see, we multiply 3 by 0, you get 0. 0 minus, or 1 minus 0 is the same 1. So you have our 1 here. We get to this side. 3 minus, we said 3 root 2. So 3, what's root 2? Our root 2 is 1. So 1. 3 multiplied by 1 is 3. So 3 minus 3, we get 0. So we have our 0 here. We are working on this half. The same thing. This half minus, we said 3 root 2. So 3 root 2, what's root 2? Root 2 is 2 and 11. So when you multiply 3 by 2 on 11, we are having 6 on 11. So 1 minus half minus 6 on 11. So we get minus 1 on 22. Same thing happens to this side. So we say 0 minus 3 multiplying row 1. Sorry, row 2, and the row 2 is 1 on 11. So when you multiply negative 3 by 1 on 11, you add negative 3 on 11. But here is 0, so you have negative 3 on 11. We move to the second row. The second row, we have 0 here, and then we have 1 here. Here is 2 and 3, 2 and 11. Here is 1 and 11. So if you can study clearly, you could see we've been able to transform our A element to an identity element. It's made up of ones and zeros, which means the values here is now the inverse of A. This is now the inverse of A. So you can say our A inverse is equal to negative 122. No, why my pen is not responding. Negative 3 and 11. You have 2 and 11. You have 1 on 11. So this is the inverse of A. So let's solve another example, since we now have the idea or how. So assuming our A, let's work on 2 by 2 matrix again. So this is our A.
Please, a question.
Okay.
Question.
Yes, please.
Hello.
Yeah, please, you can go on.
So does it mean the answer you get to be the identity?
Yes. The answer will be no. The answer
Okay,
will,
so
the answer like this one. This is your inverse, the inverse of A. So this is the final answer. So what you have to stop is when you see that all the elements of A have now changed into an identity element. When you're able to turn the elements of A to an identity element, then that's where you have to end, because your B is now the answer for the question, which means these figures is now your inverse of A, or is the solution.
okay, thank you.
Okay, so you're solving another example. I hope you get this one. So first of all, you have to argument it. So by argument, you just write 2 1 4 0, the identity element here, 0 1. And what we are saying is that we are going to change the element here to be an identity element. So that's what we are going to do. So first of all, when we look at row 2, we can see here is 0. And then what we want to see, the identity element, we want every element to be 1 1 0 0 1. But here is 0. And you know, when you multiply any number by 0, you get 0. When you divide any number by 0, you get 0. So it's not that easy to change this 0 to a unit number. Therefore, when we were starting, we said we can interchange the rows. So here, let's interchange row 1 for row 2. So we are going to get, so row 2 will now be our row 1. So you get 1 0, and the row 1 will be our row 2 2 4. As if interchange the row 1 and 2, same thing needs to happen to this side. So here will be 0, here will be 1 1 0. So now we have 1 0 2 4. So now we perform the operations on it. What do you want to see? You want to see this here to be 1, and then it's already 1. So we are okay. We want to see this 2 to be 0. So we want to change this 2 to 0. And then we said before you can change the 2 to 0, we are just taking the 2 out of itself. So it's 2 minus 2. But then you have to multiply by something. So you multiply, so the formula will be row 2 minus 2, because we want to make this 2 0. Minus 2 multiplying by row 1. Because row 1 here, on top of the 2, we have 1 there. So when we multiply 1 by 2 is 2. So here will be 2 minus 2 multiplying by 1. So 2 multiplied by 2 is 2. So 2 minus 2 is 0. So we have 1, 0. We are working on the row 2, so we don't touch the row 1. 0, 1. And then if we work on these 2, we had 0 here. So what you're going to do next is to work on this 4. And then the formula says row 2 minus 2 row 1. Now row 2 here is 4. So we say 4 minus 2. What's our row 1? Row 1 here. This is 0. So 0. You know 2 multiplying 0 is 0. So 4 minus 0 is 4. So we have our 4 here. We move to this one. The same formula. 1 the same formula row 2. The row 2 is 1. So 1 minus, we said 2 row 1. So 2 row 1, but row 1 here is 0. So 2 multiplying 0 is 0 minus 1. So here is 1. We move to this side. 0 minus 2 multiply, here is 1. 2 times 1 will give you 2. Minus 0 is what? It is negative here, so negative 2. So now you've been able to change this 1 and this 0. Here is 0. So you have to turn this 4 to 1. You have to turn this 4 to 1. So what we are going to do is that we said before you can change a number to an identity element, you have to divide it by itself. But then the division will affect all the rows. The row 2. So we said we divide row 2 by 4. So we have our 1 here. We have our 0 here. We have 0. We have 1. So row 2. So 0 divided by 4 is 0. 4 divided by 4 is 1. 1 divided by 4 is 1/4. And then negative 2 divided by 4. Negative 2 divided by 4 is negative half. So you can see that we've been able to change our A element to look like an identity element. That's 1, 0, 0, 1. Therefore, our inverse is equal to this. 0, 1, 1 on 4, negative 1 on 2. So this is the inverse for the matrix that we were solving. Let's solve one example, and then that will be all for the inverse. And this one is supposed to be 3 by 3 elements. So assuming A is a 3 by 3 element. Let me find 3 by 3 elements. So we have 2 here, we have 5 here, we have 8 here. 4, 7, 12. 4, 7, 12. 8, 0, 2. 8, 0, 2. So we have to find the inverse of this matrix. So first of all, we said we have to argument it. So let's argument this matrix. 2, 5, 8. We have 4 here. We have 7. We have 12. We have 8. 0, 2. And since this is 3 by 3 matrix, the identity that we are argumenting it is supposed to be 3 by 3. So we have 1, 0, 0, 0, 1, 0, 0, 0, 1. So now we are working on these two. We want to change these two to 1. So how can we change these two to 1? So what we say is that we divide it by a 2. So you just have to write the formula like what you are doing. The examiner need to know what you are doing. So you have to say row 1 divided by 2. You have to change this element to look like an identity element. So first of all, we are working on these 2. And we are saying that how can we turn these 2 to look to 1? So the way how we can turn these 2 to 1 is that we just divide the 2 by itself. And what you are going to do to these 2, you have to affect all the elements on this row. Therefore, we said row 1 divided by 2. So that when we divide this 2 by 2, we get 1 here. We divide this 4 by 2, and we get 2 here. We divide this 8 by 2, and we get 4 here. 1 by 2, we get half. 0 by 2 is 0. So 0, 0. The other rows are unchanged. So we have 5 here. We have 7, 0. 0, 1, 0. We have 8. We have 12. We have 2. 0, 0, 1. So what we are going to do, now we've been able to change these 2 to 1. So we are done with this first row, first element. So we are moving to this 5. What we want to do is that we have to change this 5 to 0. How can we change this 5 to 0? We say row 2. 5 is on row 2. So we say row 2 minus 5. So that 5 minus 5 will be 0. But then we have to multiply it by something. So we have to multiply it by one of the rows, so row 1, because here is 1. So that when we get 5 here, multiplying 1, it will be 5. And then this 5 row 2 is 5. So that 5 minus 5 will be 0. So we can get 0 here. So we have row 1 is 1, 2, 4, 1 and 2. We have 0 here. 0. Then this row 2, we subtract 5 from this, so we have 0 here. So we are moving to the 7. We said row 2 minus 5 row 1. So row 2 now is 7 minus 5 row 1. Row 1 is what? Row 1 is 2. So 5 times 2 is 10. 10 minus 7, you have negative 3. So here is negative 3 here. We are on this 0. So here is 0 minus 5 row 1. And row 1 is what? Row 1 is 4. So 5 times 4 is 20. Here is 0. So 5 minus 20, which is 0 minus 20, which is negative 20. So we are here. The same 0 minus 5. And now row 1 is half. 5 multiplying half, we get 5 on 2. So it's negative because there's negative here. So it's minus 5 on 2. Here is 1. So 1 minus 5 multiplying row 1. And here row 1 is 0. 5 times 0 is 0. So here you get 1. Yeah, and here 0 minus 5 multiplying row 1, and row 1 is 0. So everything is 0. So here you get 0 here. Then we write our third row. Which is 8, 12, 2, 0, 0, 1. So now we've been able to change the element on the second row to 0. So now we are moving to the 8. We want to turn that 8 to 0. So how are we going to turn the 8 to 0? We turn the 8 to 0 by subtracting 8 from itself. But then you have to multiply by a row. So we say row 3 minus 8. Because you want the 8 to be 0. Multiply by row what? The row 1, because there's 1 here. Multiply by row 1. So here you have 1. Row 1 and 2 will not change, so we just rewrite them. We have 0 here, minus 3 here, minus 20 here. We have half here, 0, 0. We have like 5 on 2 here. We have 1, we have 0. So now we are working on the third row. And we said our formula is row 3 minus 8 row 1. So row 3, which is 8, minus 8 row 1. And row 1 here we have 1. So 1 multiplying 8 is 1. It's 8. 8 minus 8, which is 0. So you have 0 here. We move to this 12. So you get 12 minus, we said 8 multiplying row 1. And row 1 we have 2. This 2. So 8 times 2 will give us 16. So 16, and then you are subtracting 12 from 16. You get negative 4. So here is negative 4. Then we are working on this one. So we have 2 here minus 8 row 1. What's our row 1? Our row 1 is 4. This is a 4 here, or this 4 here. So our 4. So we multiply the 8 by the 4. It will get 32. So 2 minus 32, we get 30, negative 30. So here is negative 30. So here is 0. So the same thing, 0 minus 8, here is half. So half. So we're going to do this, we're going to perform this same operation now until the elements all turn into an identity element. Turn into 1, 0, 0, 0, 1, 0, 0, 0, 1. And then the final answer will be your inverse. So let's continue. So here we get, is it 2? So 8 multiplying half. So you get 8, 0 minus 4. If it's negative 4 here, this place is 0, 0, and then the x value to is 0. So it's 0 minus 8 multiplying 0, which will give you 0. So here is 0. You have 1 here, and then the R1 value is also 0. So you get 1 because 1 minus 8 multiplying 0, here will be 0, so 1. So here is 1. So now we are done with the first column. All the elements in the first column, we've had our 1, 0, 0. So you're moving to the second column. You're moving to the second column. This column. And we are changing this 2 to 0, this negative 3 to 1, and this negative 4 to 0. So first of all, let's work on the 1. The 1 will turn it to 1. Let's work on that one first, which means we are going to work on this 3. And that 3 is found on the row 2. So we say our row 2. And then we are changing this 3, negative 3, to 1. And we said if you want to change a number to a unit number, you just divide by that number. So we say root 2 divided by negative 3. And this is going to affect all the root 3. So first of all, is equal to. So since we are working on the row 2, let's write the elements on the row 1. We have 1, 2, 4. We have half, 0, 0. And then we are not working on row 3, so let's write the element on row 3 too. Negative 4, 0, 1. So now we're working on the row 2. So row 2, we said, let's divide row 2 by negative 3. So 0 divided by negative 3 is equal to 0. So here is 0. Negative 3 divided by negative 3, we get 1. We have negative 20 divided by negative 3. This 3 cancel this 3. And then This negative count is negative, so you have 20 on 3. This negative 5 on 2, we are dividing it by negative 3, right? So divided by negative 3. So just punch on your calculator. Divided by negative 3. You have 5 on 6. So we write our 5 on 6 here. 5 on 6. This one divided by negative 3, you get negative 1/3. This 0 by negative 3, you get 0 here. So now you've been able to turn this one. We're able to turn this into 1. So what you're going to do is that we change the upper or the lower, the up or the down, the row 1 or row 3. Anyone that you like to work on it first, change that one to 0, 0. So first of all, let's work on row 1. So we say row 1. And how can we turn this 2 to 0? By subtracting 2 by itself. So we say row 1 minus 2, and then we multiply it by row 2. So that here, this one will multiply this 2 here, so that you get 2 minus 2 multiplying 1. It will give us 2. So that 2 minus 2 will be 0. Therefore, this place will be 0. Okay. So we have we're working on the first one here. Since we're saying row 1 minus 2, row 2. So row 1 here is 1. The first element on row 1 is 1. 1 minus 2 multiplying by row 2. Row 2 is 0. This is 0. And you know 2 multiplying 0 will be 0. Therefore, here will be 1. So you have 1 here. Then you move to this 2. So here it will be 0. Because we've already worked it here. 0. And we are working on this one, the 4. So 4 minus 2 multiplying row 2. And then our row 2 is 20 on 3. 20 on 3. So 2 multiplying 20 on 3. We get 40 on 3. So 4 minus 40 on 3. We get negative 28 on 3. So, where are we? Negative 28 on 3. So, this half. So half minus 2 on row 2. Then row 2 is 5 on 6. So when you punch everything once and then you write the answer. You have negative 7 on 6. So our next element here is 0. So we say 0 minus 2 row 2. 1 on 3 is negative 1 on 3. So give us 2 on 3. So you have 2 on 3 here. Two on 3. We work on this. Here is 0. So definitely our answer will be 0. Got 0 here. Other elements remain the same. So you write them. 0, 1, 20 on 3. We have 5 on 6. Negative 1 on 3. Negative 1 on 3. You have 0 here. You have 0 here. Make 4. Negative 30. Make 4. 0 and 1. So now what we are going to do is to change this negative 4 to 0. So the same thing. What we are saying is that root 3 equals 1 root 3. Root 3, because this one is negative 4, we say root 3 plus 4. So that negative 4 plus 4, we take it away. And then we multiply by root 2. So let's write the root 1 and then root 2 because those rows are not being affected. So we have 1, 0, negative 28 on 3, negative 7 on 6, 2 on 3, 0. We have 0, 1. We have 20 on 3. We have 5 on 6, negative 1 on 3. Is it 5 on 3 or 5 on 6? Let me check. Is it 5 on 6? We have 0 here. So now we are working on this. So we have root 3 plus 4 root 2. What's root 3 here? Here is 0. So 0 plus 4. And what's root 2? Root 2 is 0. So here is 0 plus 0, which is 0. So you have 0 here. You move to this negative 4. So you have negative 4 plus 4 multiplied by root 2, which is 1. This one will get as 0. Get 0 here. The next stage, this is negative 30. Let me print this one. So we say negative 30 plus 4 multiplying 20 on 3. So when you punch everything, minus 30 plus 4 multiplying 20 on 3. You're going to get negative 10 on 3. So here is negative 10 on 3. We do the same thing here. Root 3, which is negative 4 plus 4 root 2, just 5 on 6. You get negative 2 on 3. Negative 2 on 3. Perform the same action here. So this time is 0 plus 4 multiplying this negative 1 on 3. We get negative 4 on 3. Negative 4 on 3 here. Same happens to this. Let me clean this once. So you have 1 plus 4 root 2, and root 2 here is 0. So 0 multiplying 4 is 0 plus 1. So here is 1. So now you've been able to change the second column. So you are now moving to the third column. So you have to change this third column here to 0. You turn this place to 0, 0, 1. So first of all, work on the 1 so that you can change the other opponent to 0. So we working on the 1 means you're working on root 3. So what's the formula? What's supposed to be our formula? We want to turn this negative 10 on 3, negative 10 over 3 to 1. So one is either we divide by the same element, that's negative 10 on 3, or we multiply by negative 3 on 10. So not to be confused, let's divide by the same elements or the same number. So we say root 3 divided by negative 10 on 3. So you see when you divide 0 by any number, it's 0. First of all, let's write these elements since they are not being affected. So you have 1 here, you have 0, you have negative 25 on 3, negative 7 on 6, 2 on 3, 0. You have 0, 1, 20 on 3, 5 on 6, negative 1 on 3, 0 here. So now we're working on this with 3. So a number divided by 0 is the same 0. A number divided by 0 is 0. When you divide negative 10 over 3 by its same number, we get 1. Because it will cancel out, we get 1. So we are here. Negative 2 on 3 divided by negative 10 on 3. So you divide and you just go upside down. So you can even say times negative 3 on 10. So that's why just cancel this. You get negative. So our final answer will be 1 on 5. So you get 1 on 5 here. On 5 here. Same thing happens to this line. So we said negative 4 on 3 divided by negative 10 on 3. This will give us 5 on 2. So we have 5 on 2 here. We work on the last one, which is 1. Let me print this one. So you have 1 for root 3 divided by minus 10 on 3. We're going to get negative 3 on 10. So you have negative 3 on 10 here. So now what we are going to do is to change this and this to 0. So let's work on row 2. So we say row 2. This row 2 is 20 on 3. And then we want this place to be 0. We subtract the same number. But then we multiply by row 3 because row 3 has 1 here. So we said minus 20 on 3 multiply by row 3 like this. So let's write those who are not affected. So we have 1, 0, minus 20 on 3, negative 7 on 6. So we have negative 7 on 6. We have 2 on 3. We have 0. We have 0 here. We have 1. No, we are working on this one. Okay. So let's keep that one and then write the root 3. We have 0 here. We have 0 here. We have 1. We have 1 on 5. We have 5 on 2. We have minus 3 on 10. So we are working on the second row. And then we said row 2 minus 20 over 3 multiplying row 1, row 3. So because row 3 here is 0, so here will be 0. 0 multiplying 20 will give you 0. 0 multiplying everything here will give you 0. So the answer will be row 2. And what's on row 2? 1. So this one will be here. and this 0 2 will be here. And when we subtract this from this, we get 0 because it's 20 on 3 minus the same 20 on 3 multiplying by 1. So here 2 will be 0. So you work on this one. 5 on 6. 5 on 6 minus 20 on 3 multiplying row 3, and row 3 here is 5 on 2. It's 5 on 2. You have negative 95. Here we have negative 95 here. Oh, I use this one. Sorry. I'm supposed to use this one. Not this. So here will be 105. Here negative 1. Here will be negative 1. You work on this one. Negative 1 on 3 minus 20 on 3 multiplying with 3, which is this one, 5 on 2. It will get negative 17. So negative 17. And then last one here is 0. Let me write it here. Here is 0. 0 minus 20 on 3 multiplying negative 3 on 10. Okay. So we get 2 here. Okay, so we're left with only 1 here. So I want you to do that one for me. So change this one to 0. So you change this to 0. And then the answer that you get, because you've changed all the elements of this one, so change this one to 0, and then the answer you get here will be your inverse for matrix A. So this is where we are going to end for today's lesson, and then in our next meeting we will learn about how we can transform linear inequalities to matrix and how to find the values in the linear inequality when you're given an equation that you have to find for the variables or the coefficients, how you can use a matrix to solve for those coefficients. Okay.